Okay, so today the main goal is to finish the topics about polymorphism and dynamic binding. We'll talk about some very interesting cases about cast. You'll be amazed what you can do with cast, but you gotta be careful with what you do. I do prepare some additional notes for you. So if you go to the lectures website over there, you will see there are notes on static types, dynamic types, and casts. So there's a PDF with about only 5 pages. So I would suggest go over them. So it talks about basically what I'm going to say in the class today, but it's like a written form. Hopefully you can also strengthen your understanding. But I'm gonna go over everything with you as well in the class. Again, although the cast and polymorphism and dynamic binding we use IFO syntax to talk about them. Try to link what you learned in Java as well, or C# or C++. They're all transferable concepts. Okay, so the syntax we use is IFO. Okay. Okay, let me review very quickly about cast. So we talked about last time. Hopefully you got a chance to review over the past weekend until this slide over here. So why do we need cast? We need cast because sometimes we find that the IFO compiler or Java compiler, they are not so flexible. For example, let's see, just for this line of code over here, let's say we got this gym over here. Gym has the static type students and then dynamic type resident students. And we are trying to assign gym to RS. Apparently we cannot do this because the static type of gym is not a descendant class of the static type of RS. That's something we have talked about. However, in this particular case, we are pretty sure the dynamic type of gym is really residence. So there should be no reason that we cannot force the compiler to do it. And the way to do it, pretty similar to what you did before in Java, we can do a cast. Okay, so this is what we can do as a cast. So now one more thing I added to the slides, you can think of the way you do the cast is to temporarily, only temporarily, not permanently. You only temporarily change the static type for the variable you're trying to cast into. Okay, so that's something you can we'll see today. Let's see again the syntax for cast. So now the IFO syntax for cast, basically everything you do over here, you got similar correspondence in Java as well. Okay, so you have some check expression over it, check, then, and end. What's within the check is some Boolean expression over here. We're trying to say, let's try to cast gym into resident students. Let's try to temporarily change its static type into resident students so we can do something that's specific to resident students. And then we try to say, if the cast was successful, cast that variable into RS gym. Okay? Otherwise, you're gonna have some check assertion violation at the runtime. Okay? I remember one of you actually got a question. I'm gonna address that in just a moment at the end of the slides. Okay, you can read over the meaning for this particular check expression. You also got the similar cast in your lab number 3. You can check the test cases for that. Okay, so now if you see the corresponding Java code, it is something like this. So one of the questions you had last time was, in the IFO version, we had to explicitly specify an extra local variable over here, rsgym, so that it can be used within the context of the check expression. So you got some concern about whether this might be inefficient since we are introducing an extra variable. The answer is no, not necessarily, because if you try to consider this Java expression over here, we are trying to cast gym into some resident students type. But remember, this line over here is actually somehow we do the cast and then assign the cast version into rsgym. So there is also some hidden variable created under the hood. Okay, so we are really doing the same thing. It's just that in IFO, we're just trying to make this variable explicit. Okay, but it has to be created anyway, intermediate. Okay. Any question about the syntax for the cast before I go on? So that's pretty much where we left off from last time. Okay. So please make sure you are used to this syntax here. You got that in lab number 3, and hopefully you can also see that. Okay. We're going to talk about attached after the reading week. So when we talk about voice safety, we'll eventually get there. But for Thursday, I would like to talk about some design patterns just to get you engaged in another respect. But this attach over here simply means we are trying to cast this particular object into a particular type. If it succeeds, that means it will be attached to some certain objects. Otherwise, it will be void. Basically, that's what it means. Okay? But we'll get to the attach maybe next week. Okay, so now let's talk about the rules about how you can do the cast. Okay, I do have some rules over here. It's a little bit dry, so I'm going to use an example to show you. Again, if you look at the PDF I just mentioned in the beginning of the class, you can also see that explanation in detail. Okay, that's something I will leave that to you. Okay, so let's try to read this rule very carefully over here, just very briefly. So what kind of class can you cast an object into? Again, we have to, every time we do cast, it has to be with respect to some inheritance hierarchy. Okay, so now let's say I'm trying to cast some variable v into class C. I'll give you an example in just a moment. So what cast will be allowed? It turns out you can cast v into any class that's either an ancestor class of its static type or is a descendant class of its static type. Either way, you can either go upcasting or downcasting. Okay. One more thing to mention before I show you an example. Every time you do the cast, remember you temporarily change the static type of your variable. And when we talk about static type, it really defines the expectation of what you can call on this particular variable. Let's say if I declare my S variable as students as a static type, that means I can only call student-specific features on S. On the other hand, if I say RS is declared of type resident students, I can call more, right? So that's really about expectation. Let's see example. Why a cast? Because we can try to call more features or fewer features. Okay. Let's just try to see some example here, and I'll draw you a diagram. Now let's say we got my phone, which is declared as iOS. Oh, let me just review the hierarchy with you very quickly. Okay. Otherwise you get lost. Okay. I forgot to use QuickTime. Let me do that quickly. And then let's consider a new inheritance hierarchy. Okay, so now let me review that very briefly with you. Okay, so this is an inheritance hierarchy for smartphones. At the top level there, we have smartphone. Okay, under smartphone, we might have either iOS or we might have Android. Okay, under iOS, we might have iPhone 6s or we might have iPhone 6s Plus. Okay. Under Android, either Samsung or HTC, and we got specific brands under each company. Okay, so now let's just go over the features we have for each class. Let's say for the smartphone here, we got a basic functions like a dial and also surf web. Under iOS, we'll certainly inherit the dial and surf web. But let's say in iOS, we try to redefine the surf web. Let's say we try to surf the web using Safari, the default web browser in the Apple. In Android, we also try to redefine the surf web using, let's say, Firefox. Okay? And in iOS, we are trying to add a new feature to it. Remember, every time when you go to a descendant class, not only that you accumulate the code from the ancestor classes, but also you try to define new features. In this case, for iOS, we got FaceTime. Okay? Let's say for Android, we got Skype. Okay? Just as an example. Let's say for illustration purpose, I didn't put it on the diagram, I'll put it after the lecture. Let's say for iPhone 6s Plus, we also got one more feature, a new feature called 3D Touch, for example. 3D Touch. So this is specific to iPhone 6s Plus, only that. Okay? Any question about this hierarchy here? We're going to use this as a running example for today. Quite a few examples. Okay, having this in mind, let's go back to the slides and try to do some illustration here. Let's say we have my phone, the static type is iOS. That means we can only call iOS specific features over here. More precisely, we can call any features that are either defined in iOS or any of its ancestors. Any of the ancestors that has been accumulated into iOS. Now let's do cast. The rule is very simple. Let me just illustrate to you. What's the rule for casting? And then we'll talk about the effects of doing such cast. So what we have is, we have my phone. My phone is iOS. That's a static type. So now let me highlight that. I'll use green. So iOS is the static type for my phone. So this is the static type. Let me use green just to be consistent. So this is the static type of my phone. Now, let's illustrate the rule diagrammatically. The rule is you can cast my phone to any type, any class that's either an ancestor or descendants of my phone, the static type. Okay? What does that mean? That means it can be ancestor. In this case, we only got smartphone. Only that. Or we can go to any of its descendant classes, which can be this or that. So if you try to cast my phone to any of these 1, 2, 3, 4 types, it's considered as compilable, which means things will compile. But things compiling doesn't really mean you wouldn't get any runtime violation, like a class cast exception at the runtime. So we're going to these two issues separately. Okay? First of all, let's think about if you try to cast my phone over here into either iOS itself or to smartphone or to iPhone 6s or to iPhone 6s Plus, what's going to happen? What's the consequence of doing that, right? We want to know. Remember again, casting only temporarily changes the static type, which means it changes the expectation you have on this particular variable, i.e. the features you can call. Let's see, okay? Now let's see one by one. Let's see over here, let's say for now, we have dynamic type of my phone being iPhone 6s Plus. Okay, I will also annotate that. iPhone 6s Plus. Okay, so this one here is dynamic type of my phone. You can see they don't have to be the same class. So now the static type is iOS, dynamic type is iPhone 6s Plus. And now we're going to consider different casts, okay? First, number one, so once you define this, so remember as is, my phone has static type iOS, so you can only call the features on iOS. Okay? So what are they? You can call dial, surf web, and FaceTime. Okay? You can see that over here, you have dial, surf web, and FaceTime. So these are the only three features you can call. For example, you cannot call 3D touch because it's too specialized. Okay? So far so good, right? Okay? Let's see the more interesting bit. And 3D touch is 3D touch and Skype. So why not Skype? Because Skype is over here. Nothing to do with the ancestor or descendants. Nothing to do with it. Okay? Guys, any questions, please let me know. Okay? Okay, let's go to the next example, next one. The same variable here. Let's say we try to cast. Let's now do an upcast, which means we are trying to cast this particular variable to its ancestor class. So what does that mean? That means ancestor class we can expect less because they got fewer features in the ancestor. But it's still compilable. You can still do that. But what's the consequence of that? So now if you say my phone is cast as SP has static type smartphone. In this case, what can we call? Well, we can only do dial and surf web, but not other features anymore, right? For example, like a FaceTime. Let's do a contrast. Before that, let's say for this line over here, this line up to now, the static type of my phone is simply iOS. That is why we could call this particular FaceTime feature over here. That's why. But now let's say we do a cast from my phone into some smartphone over here, the green one over here. After that, now we got less expectation on this particular variable, only for the feature that are defined in smartphone. In this case, what can we have in smartphone? We only get dial and surf web, but not the FaceTime anymore, not anymore. Okay? Guys, any question about this first cast over here? Any question? It is compilable. You might be wondering why you need to do that, right? Because somehow, if you declare that initially to be iOS over here, but you're now casting that to something that's less specific, it could be for access control. I wouldn't elaborate too much. Let's say you're supposed to give somebody some objects. You don't want to give them all the access to, let's say, FaceTime or 3D Touch or other features. You can just give them a more general static type. So they can only call certain smaller set of features. Okay? But we only talk about the rules for now. Okay, let's now do, yes, go ahead. No, it doesn't. So now, number one, when you read the document also, when you do cast, you only temporarily, not permanently, temporarily change your static type, only that.
Okay, so if you have another variable, say, that,
yeah. Good, very good. Okay. Guys, by the way, all the source code is also available in the package. It's just updated that. You can always try. Okay. Okay, so now, let's see this one over here. Let's say for this third cast, we say that we cast my phone, which was declared as iOS, into iPhone 6s Plus. Okay, let's see what the picture is. Sorry. My phone, the static type is iOS. And then we're trying to cast that into iPhone 6s Plus, so that's downcast. Once we do the downcast, what does that mean? That means we can now call this particular feature that's only specific to iPhone 6s Plus. Okay? So once you have done that, you will see that over here, not only that we can call dial, surf web, FaceTime, we can also call 3D Touch. The only thing that we cannot call just yet is Skype. Now, question for you. Is the following cast going to work? It's not on the slides, but I'm going to write it here. Is this cast going to work? Is the following cast compilable? Would it compile? So we still got my phone being iOS, and now let's say we say check. Let's do a cast. Attached. And then let's say we really want to call the Skype feature. You will see all the three casts we tried to do over there. They didn't allow us to do Skype because the static type has nothing to do with enjoy. Why don't we try? If you do enjoy over here, and then put my phone. Let's say S, I'll just say enjoyed. And then, okay, these are keywords, and then you can do maybe something over here using enjoyed. Is this going to work though? Is it even going to compile? No, right? So don't be, hopefully that strengthens your understanding over here. You can see that enjoy over here has nothing to do with the ancestor, nor has something to do with the descendant classes. So you wouldn't even compile. Okay? The cast rule is very simple. You can cast either to do upcast to the ancestor class or downcast to any of the descendant classes. But now, and then the consequence is the features you can call on the cast version is different. If you do upcast, you're basically allowing fewer features to be called on the cast version. If you do downcast, you're allowing more features to be called on the cast version. Okay? But when, go ahead.
We can only cast once. We can't cast to the smartphone and go back down and
Actually, you know what? That's a good question. As you can see over here in the slides, for the same my phone over here, you can see over here, first time and second time, we're trying to cast the same. So whenever you're doing a cast, there's an intermediate variable that's being created. So that's stored the cast result. So in this case, for the first cast, we try to use my phone, but itself is untouched. So we just create a cast version called SP. And then for the second one, we create another cast version called IP6S Plus. So you can cast more than once, yes. Yes.
So why can't you cast a variable that was just cast?
You can also do that if you want to. So here, I just showed, for simplicity, I'm trying to cast the same variable to show you the effects.
Right, well, okay, so you have iOS.
Yep.
Can you cast to the variable .sp? Can you then cast sp to Android?
Can you cast SP to Android? No, we cannot. Oh, I see what you mean. I see what you mean. I believe you try that. You know what? That's a good question. If for the theory to work, I think that should work, but you might run into runtime assertion error. You know, guys, that's a very good question. How about let me try this on my computer offline, and then I will bring this up again on Wednesday. It's a very good question. Again, the question was, very good question. I said you can either cast upwards or downwards. Let's talk about the second cast over there. We got SP. Now, SP has the static type smartphone, which pretty much on the top. Every class involved is the descendant class. Can I cast that into Android? My gut feeling is you can, but you might run into trouble at the runtime. Let me try this on myself offline, and I'll make some new slide to illustrate this. I think that's a good question. Okay, let me try. Very good question. Anything else? Yes. You mean this one here? Yeah, so this one here, just what we said before. So this one here, it's not a cast. It just creates some objects. Yeah, so this one is pretty much like a new and then some class name. Yeah, so that's why we use the red over here, right? Okay. Okay, let me just go on. Okay, so now, here is actually even more equally important. We know that we can either do upcast, we can either do or downcast. That's certainly fine at the compile time. At the runtime, you cannot do just whatever you like, depending on what the actual dynamic type is. Remember again, every time you talk about whether something compiles or not, you only consider static type. But now, if you talk about the behavior or any possible violation at the runtime, you have to consider dynamic type. Let's see in this case, okay? Okay, very briefly before I go through the slides, basically over here, you can see that, let's say, let me just have a fresh picture, okay? Okay, over here. Okay, again, let's bring up to the same page. So we have my phone is iOS. So this is the static type. Meanwhile, we have this being the dynamic type. Of my phone. Okay, that's from the previous slide. Let's consider a new example, a new one. Let me be consistent with the name. I kind of forget how I call the variable name. It's called mine, okay. Let's consider another case. I'm going to put it on the diagram as well. So let's say we got another phone called mine over here. Oh, thank you, thank you. Android over here. Let me just also get rid of that. Good. Android. Okay, this is the static type. Okay. Now, let's say Galaxy S6 Edge is the dynamic type. Let's say this is dynamic type of mine. Okay. So now this example is a little bit even bigger than the previous one. Let's review what we just learned from the previous slide. In terms of if something compiles or not, what can we cast mine into? How about this? Let's make it simple. What can you not cast mine into? iOS, iPhone 6s, and iPhone 6s Plus, right? Okay, that's easier. These are what you cannot, what you can't cast mine into, according to what we learned from the previous slide. Okay, so that means you can cast mine either to this, or this. However, you can see that at this particular time of moment, the dynamic type is actually Galaxy S6 Edge, right? Now, if we try to cast the Android into, let's say, HTC, it is going to actually compile because that's a descending classes. Now we talk about compilation. But at the runtime, is it really going to be okay? It turns out no. Okay? Why? Think about intuitively. Let's say this. Because HTC is just a new class from Enjoy, right? Just a new class. So there might be certain features we define that's completely independent from Samsung. I'll just say HTC feature over here. Just make it very generic. And this feature here is simply not supported by the Android. It's simply not supported. So this is going to run into trouble. Okay? So now there's another rule you have to obey to make sure you have no runtime assertion violation. So what is that? You want to make sure whatever you cast your class into, they have to be an ancestor of the dynamic type. Okay? I'll just write it down and then we'll see some example. The rule is to avoid runtime violation you should cast mine into one of its dynamic type ancestor. Okay, that's a rule. And again, when you see the PDF, also is I'll just tell you in detail. Let's see some example in the class. Okay, so which means in this case, if you try to cast that into Samsung or Android or smartphone, that's fine. If you try any of the HTC or this one or this one or this one, they are not considered as okay. You'll run into trouble. Okay. Okay, let's go back there and let's write some. Okay, so it should be along the ancestor path of the dynamic type. That's the rule for the runtime. Okay, so again, just to make a cast to compile, it has to be either ancestor or descendants, only the static type. But when you talk about whether there's going to be a violation at the runtime, you got to take dynamic type into play. And the type you cast the variable into must be along the ancestor path of the dynamic type. Okay? Again, the rule is a little bit tricky, but again, all we are talking about is about the expectation of the variables. Okay? Okay, let's see this very quickly. Okay, you have seen that already. Okay? So now let's say we have mine. Oh, actually, I got a little bit different example here. Why don't I try a new diagram? I'm going to put it first, and then we'll go through that again. Okay. Okay, image, and then photos. Okay, that one there. Sorry. So bear with me. I just want to create it in a separate page. Image, photos, and then. Okay, so what we have is Android and Samsung. Okay. Android, so this is the static type of mine. And also we have Samsung, okay? So this is the dynamic type. Okay, let's keep that in mind. Okay, again, you can also do the practice as far as the compilation is concerned, what can you cast it into? That was easy, either ancestor or descendants. But now, you can see the only classes that you can cast that into and also is runtime assertion violation free. In that case, the only classes you have is only Samsung itself, ancestor, or ancestor. So these are the only three classes that you can cast that into without any compilation problem and without any runtime violation problem. Okay. Okay. Let's go back to the slides and see what we should say. Okay, you can see you can either do some smartphone or itself, or you can be also, now if you try HTC, you're gonna run into trouble, right? Because it's neither, it's not along the ancestor path, it's just completely independent, okay? Okay, so now let's try this one here. This is more interesting. Let's try this case over here. HTC, somehow the reason is obvious because HTC is completely irrelevant to the Android. What about Galaxy S6 Edge over here? Let's see where it is in the inheritance hierarchy. down over here. Oh, thank you. Sorry, wrong way. Thank you. Good. So now I'm trying to let me write it down. When I say check attached, so Galaxy S6H, something like that, and then we got mine over here as, I'll say P, just some phone, and then end. Let's think about, first of all, this will compile because it's one of the descending classes. However, this is going to cause some runtime violation simply because this class over here is not along the ancestor path of the dynamic type. But we can think about why. Let's get some intuition from here. Why would that be the case? What if this was allowed? Let's think about it. That's again proof by contradiction. Remember the last time I did proof by contradiction, I said about polymorphism, either S is assigned to RS or RS is assigned to S. I tried to prove by contradiction. Similar idea. I'll give you some idea over here. Let's say, hypothetically, let's say there is, so this is a subclass over here. Let's say there is a new feature, I'll say NF. So this is a new feature in this class over here, just a new feature, which only exists in Galaxy S6H, only that. We are free to add any new features there. Now, if, that's proof by contradiction, if this cast was allowed, in that case, we have two facts over here. First of all, dynamic type of P. What's dynamic type of P? Should that remain to be Samsung, right? It should remain. Because we are trying to cast mine into Galaxy, but the dynamic type, the actual object, has not been changed, right? Dynamic type of P remains Samsung, which is here. Remains the same. Dynamic type doesn't change in this case. We only change the static type. So now, second, the temporary, I'll say temporary for now, temporary static type of P is Galaxy S6 and H. Okay? If now the static type for P has now become Galaxy S6H, what does that mean? That means it will be expected to call P dot new feature. And this new feature is exactly the one I just talked about, new feature. That is specific to the Galaxy S6H. But now, would this run into trouble though? It would, right? Because the dynamic type is actually Samsung over here, which does not know about new feature. But expectation said you should have it. So we got contradiction here. Okay? So now I'm going to write it down here. So here we got contradiction. We expect to have P.NF, but P's dynamic type Samsung does not support. Okay, that's a very brief proof, informally. Guys, follow, or should I do it again? I wouldn't mind. Okay? So somehow you see the way we prove to say why we got this kind of error is, why don't we assume it's going to be okay? Then we're going to run into contradiction, right? Guys, are you okay or okay? I would say try the PDF document. It also said something like that. Okay, just go over it again. Of course, you can rewatch the video if you like. If you're okay, I'm going to go over to the next one. Okay, we're going to find more and more useful stuff. Especially you can. Feel free to link this to your Java or C# or C++. Feel free, since we talk about object orientation. They're all transferable. Okay, now, let's go back to our very initial questions. So why do we need inheritance? Remember, when we first talk about inheritance, we talk about code reuse. We got, let's say if you don't have any inheritance, how do we store all three kinds of students? Let's say the two kinds of students in our system. You got to have a separate list for resident students. You got another separate list for non-resident students. That's not very convenient. You're going to have lots of smell in your design because of duplication. So now, once we got the inheritance, this is what we can have. Okay? Let's say we got a student management system. I'm going to show you just the design after we have inheritance. And then I will show you, again, some rules you have to follow, just based on what we have learned so far. Okay? Let's say we got students over here. We only declare students over here. Okay, you can see that's only students here. Okay, so what does that mean? That means the static type, since we talk about decoration, the static type for every element in the list is students. Now, if you have students on the left-hand side of the assignments, what can you assign to it? It can be either resident students or it can be non-resident students. So that's the intuition. We're being very general, very accommodating, right? Once you have inheritance, you can always try to say, if I want to have a collection of stuff, put the static type of the collection being the superclass. And then you'll be accommodating enough to accept any subclasses, okay? That's the intuition. So now let's see what we can have. So now you can see add students over here. Let's just see the cleanest version. I'm going to show you a systematic way of figuring out how this works. Let's say we got add student here, and then we simply say S is of type students. And now we can simply extend that particular student into the list. Okay? And you can also try to say register all the students with a common course. Now you don't have to do them separately. You can simply say do a cross and then just do register for every student. Because when you talk about S over here, it's of type static type students. It's guaranteed to have the register feature. Okay? Okay, so now if you run the test cases, let's say this. Let me show you this very quickly, and then we'll go to the little bit theory. Let's say we got, let's say RS, NRS, so the static type are specific, either resident students or non-resident students. And let's say we have RS, premium rate 1.5, NRS, the discount rate 0.5. Okay? And then let's say you can see now these two lines are really critical, which you could not do without the inheritance. Okay? These two lines, SNS.add students, you can pass either RS or NRS. Both are possible. Okay? And then you can register all the students. So now both Jim and Jeremy, these two kind of students have been registered for the common course. So now if you try to do the following, if you say SMS.SS, SS the linked list, get the first students from the management system and get the second student from there and call the tuition on them. In this case, because of dynamic binding, for the first one here, it's going to be retrieving this NRS over here. So dynamic type is NRS. So it's going to call the tuition that applies to these premium rates. And the second one over here is going to be the tuition version for the Jeremy over here. That's NRS, right? So one is RS, the other one is NRS. Guys, follow, or should I draw some diagram to help you? How about this? Let me leave the diagram a little bit later because we'll see that in the example. Okay. Now, let's now get systematic. So the previous slide just to show you how clean the design can be by using inheritance. But now let's see more technical information here. Let's see a little bit different type over here. Let's say we got student management system still, and we have SS for students. We got an array of students. And the reason I put green here is because each element in the list or the array has the static type students, okay, as I said in the comments over here. Every element is with some value index I. Now, let's say we have add S over here, and then we say S is of type students. And then we can say SS0 is assigned to S. This one compiles. Let me give you a different variance. I can also say add RS. Now I can put a different static type for the parameter. It's now a resident students. Okay? And then I can say SS0 is assigned to RS. This one also compiles. okay? But we're gonna see why, right? Another version here, so we got 3 versions of add students, 3 versions, right? And the third version there, the parameter type is non-resident students over here. And then we have SS0 is assigned to NRS, okay? Now, can anybody try to explain to me? Let's keep things simple. Line number 3. Line number 3 here, the body of this feature here is only one line. SS at position 0. Don't worry about the correctness of the implementation, just there for illustration only. Okay? SS at position 0 is assigned to S. Would this compile? I can tell you it compiles, right? Why does it compile? How would you apply what you learned so far about polymorphism? Again, since we talk about compilation, you only consider the static type. Yes, do some?
The static type
As we declare over there, yes. Mm-hmm.
and you can assign to an ancestor or descendant.
No, only one way. Yes, you can only assign to ancestor. You cannot assign to descendants.
So for dynamic.
No, here we only talk about compilation, so we don't talk about any dynamic type. Okay? Anybody else want to try again? I think a do something is getting very close. So to judge if this line here should compile or not, you got all the information you need. You don't even need to know what the dynamic type is. Descending class of itself. Okay, that's exactly correct. Let me repeat that, okay? And then we got a little bit more challenging in the next line, okay? The reason that this compile is because, again, we are judging if this particular assignment here compiles or not. For compilation, only look at the static type. What's the static type of S? Look at its declaration, which is over here. Static type for S is students, as you can see over here. What is the static type of SS at position 0? This one's a little bit implicit, but it's not too bad because, as you can see over here, we declare SS to be an array of students. This is declaration. That means every element we store in this particular array has the static type students. Okay? So now you can see this one here, S, has static type students. SS0 also has static type students. Student is a descending class of itself, so this compiles. Guys, okay? Anyone want to try this? Why does it compile? NJ, you want to try? Okay. You can, can you just make it one sentence? Static type of what? Always try from the right-hand side.
Static type for the student RS is a descendant.
The static type of SS0. Very good. Very good. That's exactly what I want. Okay. So now you can see that RS over here was declared as a resident student. And resident student is a descending class of the static type of each element in SS, which is students, right? That's why. Okay, similar argument for this. Okay, you can apply that. Okay, now. Okay, so this is valid because what we have over here. Now let's get to something that's a little bit more challenging. Over there, we only talk about assignments in this particular context. Let's talk about what does it mean when we pass objects as feature arguments or as method arguments. What does it really mean? We also got a subject to certain rules. To understand this, we have to understand, remember in 2030 you learned about call by reference. Anyone want to review the concept, call by reference? Anyone? Give it a try. I promise you wouldn't be on lab test 2. Don't worry. Just give it a try. You want to try? Call by reference. Hint, it's as opposed to call by value, if that helps. Okay, go ahead.
When you assign a variable to the same reference as another.
It's kind of the intermediate step, not as a first step. You're getting somewhere, Anybody want to try? Yeah, NJ.
Will you refer to attributes to the same address in the memory?
Somehow you're making a copy of the same address, somehow, right? So, okay, this is a callback reference. When you are trying to call a method, let's say in Java or iPhone, when you're trying to call a method and you pass an object as the argument for the method call, you're not really passing the object directly. You're only passing a copy of the address of the objects. Okay, if that makes sense. Okay, that's callback reference. I'm pretty sure you know about that. Just forget about the fancy name. Okay, that's important actually. We'll see why. Okay, let's say over here, callback reference. That's a name. You can feel free to refer to your Java textbook, or I believe in OSC2 they also got the name. Let's say this. We're trying to do SMS. Let's say SMS is an instance of student management system. SMS.add resident students. And we pass some objects O. Let's say O over here. Let me just tell you that. First of all, you can see we are calling this particular feature @rs, which is here. Let's highlight that. If you look at this feature here, what it tells you is the static type of its argument or parameter rs must be resident students, right? The static type, right? And then because of call by reference, when we try to make a call like over here, okay, add rs and o, we are basically trying to make a copy of object o and then assign that copy there into rs. That's basically what we're doing for call by reference. And that's exactly this assignment over here. rs is assigned to o. I'm just trying to bring you from feature call into the context you are more comfortable with, right? So now, any question about going from a feature call or method call over here, where you got O over here, into the assignment where you say O is assigned to RS, right? RS is basically the parameter over here. Any question about this? And if you try to also apply your knowledge before lab test 1, we talk about reference copy, right? Sorry, not shallow copy. We talk about reference copy. When you do assignment over here, if both are reference type, you're only doing a copy of the address, right? That's exactly what call by reference is. Guys, questions? Are we okay? Okay, if you're okay, so now the rule for, so now we're going to consider in the next slides various different examples of making a feature call like this, add rs and some object o. And we know that you can interpret this particular feature call passing the arguments as an assignment over here. So now, just for this alone, what's the rule? By the way, there should be no semicolon. I'm going to get rid of it. Okay. So now, what should be the rule for that particular assignment there? rs is assigned to o. Just review quickly. You want to try? What's the rule? What I can pass? They don't have to be the same type. Yeah, which descendant or ancestor? Of what? That's okay. That's anybody? Just want to try very quickly, and then we can move on. Go ahead. I like that answer, except that you should say the static type of the left-hand side should be ancestor of the static type of right-hand side. Very good, very good. So guys, I would say it's up to you, your preference. You can either say, okay, the rule is as follows. Both are equivalent. You can either say the static type of O is a descendant class of the static type of RS, or vice versa. The static type of RS is an ancestor class of the static type of O. Either way, okay? You can write both in the test. Both are okay. Okay, having this in mind, okay, so it depends on the static type, and then, so now we're gonna see examples. Let's try to judge to see how good you are, okay? I've got a list different, I really try to exhaustively enumerate all the possibilities so you can really see how things will play together. Okay, let's set things up. It's a test case, it's also available on your sample code. Let's say we try to have S1, S2, S3. their static types are simply just students. RS, resident students, NRS, non-resident student, consistent with our naming as before. Also SMS, student management system. Okay, let's say that's the initial setup. The reason that I did not highlight the dynamic type is simply because to judge if things will compile or not, they are not important. They are not relevant. Okay, so now we got SMS, initially empty, and now we got S1, S2, S3, RS, and NRS. Dynamic type simply doesn't matter. Simply doesn't matter. Let's try one by one. Will this compile or not? The first one. Okay, you know what? To be really fair to you, since I don't expect you to memorize the signature, what about this? I'm gonna write in the next page the signature to remind you very quickly. So we got 3 features: add, as students. Okay, just this one. Okay, that's a signature. And should this compile or not? Yes, because but you don't have right hand side here, do you? The opposite. That's okay. But if you write it in the test, it'll be wrong. Okay. So this is what you should say. Okay. Let's see this. Now S1 is going to be assigned to the S over here. Okay. So now the static type of parameter S1 or argument S1 is students. And students is a descendant class of the S over here. Static type is students, right? Guys, are you okay for the very first one? Hopefully the first one, once you get through, it will be much easier. But if you got questions, you better ask now. Okay, we're okay. Very good. Next one. How about this? So now for this one, I'm a little bit concerned because over here you can see S1 and S2, their dynamic types are different, right? Would it affect anything? S1 and S2, they have the same static type, but their dynamic type are different. Is it going to affect anything though? Is it or is it not? Only for compilation. Then it should be fine, right? Okay, very good. You know, I'm trying to mislead you. Hopefully you will see that, right? So now you can see that even though S2 and S1, they have different dynamic type. One is student, the other one resident student, but this doesn't matter. As long as the static type matters. That's the only one that matters. So this one should compile. Similarly, S3 also compile. You can see that, okay, what about the next one? Will this compile or not? It would or it would not. Be careful here. Now, before you were lucky, you got student and student. Even if you got the direction wrong, you will still get the right answer. But this one here, be careful. Would this compile or not? And to be fair again, I'm going to remind you about the signature for add RS, which is here. Add RS, resident students. So that's the signature. Oh, actually, we are not even talking about that, right? I'm getting myself confused. Sorry about that. Okay. So over here, would it compile? Yes, right? Because the static type of RS, which is resident students, is a descendant class of the static type of students. Okay, very good. Okay, thank you. Okay, similar. This will also compile. You can see that we try different static type and different static type over here. Add S will accommodate every one of them. Okay. Now let's try to be a little bit more restrictive on the parameter type. Okay. Now this one. Add RS. Now I do want to remind you, that's what I meant to write. Add RS, the parameter type is RS, static type. And now we are trying to say add RS S. Compile? No, right? Because the static type of S1 is students, which is not a descendant class of the parameter type, which is RS over here. Okay, that's how you judge. Okay, I think maybe, hopefully, maybe once I will give you some exercise so you can practice throughout the reading weekend. So that's something you can see exactly what I expect for you during the lab test. Okay, this one doesn't. What about this one here? No, right? You see, this one's interesting. This one can be confusing. If you look at S2, the dynamic type is resident students. You might think this is okay. No. Compilation, only the static type matters. Only. Okay, be careful. This one also no. Okay, how about this? S3. No, right? Also, however, let's see this. Let's say you try to, I can tell you something, I'll just mention that verbally. Let's consider this line over here. If you said that the answer is no, but if you give me the answer as follows, that's also wrong. You said this line over here does not compile because the dynamic type for S3 is non-resident students, which is not a descending class of resident students. That's wrong. Because you got to talk about static type, not dynamic type. Be careful with your reasoning, right? Okay. So now, what about this one here? Is this okay, though? Yes, right? You want to try? Why? Static type. Yeah, it's okay. Yeah, go ahead. Yeah, go. Sorry for terrifying you. Yeah, go ahead. Yeah. Yeah, I should say the static type for RS, the argument is resident students, which is a descending class of the parameter type, right? Okay. Okay, guys, I think you got the intuition, but you got to practice more. Okay. Okay, that's good. You can see that now for at RS, the only thing that's allowed is when the static type is exactly resident students. If you got a static type either students or non-resident student, no, it wouldn't compile. You can see in this case, at S is much more accommodating than at RS. Now, rather than wasting too much of your time, tell me something. If I try a similar 5 possible argument passing over here, there's going to be how many that will work? How many? Oh, sorry, the question wasn't so clear, right? So you can see that, let me make my question very clear. You can see that in the case of at S, you can see all the 5, 1, 2, 3, 4, and 5. All of them compile, check mark. In the case of at RS, we got only this one got a check mark, only 1. Now, what about the case for at NRS? How many will have a check mark? Which one? NRSSD, right? Only when the static type is actually its descending class. And non-resident student is already at the bottom of the inheritance hierarchy, only itself. Exactly right. Okay? Guys, any question about this? So the main lesson for these 2 slides are, I'm trying to say, when you consider feature call or method call arguments, we are not really learning something new. It's the main, to fill the gap, is really about call by reference. And call by reference is really doing some reference assignment. And when you talk about reference assignment, you got left-hand side, you got right-hand side. You go back to where you're comfortable with. Okay? That's my point. Okay, good. Let's go on. Let's do another example here. Return values. Okay? So this is something, I'll try to draw some diagram as well to show you. Okay? Return values. I think this might be the last subtopic, and then I'll try to conclude by giving you some advice in terms of design. Okay? And maybe we can finish earlier today. Maybe. Okay? Maybe. Okay, let's talk about return values. Let's say we got student management system here, and then we got SS. Let's now talk about linked list, which means every element in the list has the static type just students. Just that. Okay, we got add S over here. Now, you can see that S is the static type for the left-hand side of the assignment, right? Now, what about the right-hand side? It can be any static type that is either students, resident students, or non-resident students, right? So now let's consider a new feature over here, right? So you can see that the reason I talk about new feature is because now I want to switch our focus from parameters into return value, okay? Actually, return value is not too bad. Yeah. You gotta just be clear about what's going on at runtime. Okay, so now let's say a very simple implementation here. If I say get students 1, that means I want to get the very first students from the linked list, or 2 or 3, because linked list, the indices start with 1. And then I simply say result is assigned to SSI. Okay, again, there should be no semicolon. I should get rid of that. Okay, now we know pretty well from the previous discussion that line number 5 should compile. Okay, what about line number 10? I need justification. I agree it will compile. Yes, please. Try to be as complete as possible. One sentence, if possible. Mm-hmm. I can see what you mean. I would say that's correct, but let's try to be a little bit more rigorous in terms of argument, okay? Let's try, okay? Again, we know that we want to judge if line number 10, which is an assignment, will compile or not. We're going to look at the static type on the right-hand side and the left-hand side. What's the static type for the right-hand side? Students, because we declare SS to be linked list of students, okay? And then what's the static type for result? How do you look up the declaration though? What's the result? Result is return value, right? So what's the return type? What, student here, right? So now, so this is the perfect answer, I would say. If I give you 40 marks for this particular question, that'll be the 40-mark answer, okay? Of course, that wouldn't be 40 marks for sure. Let's say how we can have a perfect answer. The static type for SSI is students, and that is a descendant class of the static type of the result, which is also students as declared over here as a return type. That's a perfect answer. Yes? Yes, exactly. So now, that's a very good question. So now, if just in case you're still confused, how would you figure out the static type of SSI? Okay. First of all, you can see that SSI, the reason that we got index operation is because we got a collection over here, right? And you got SS over here. It's a collection. It can be array, linked list, or maybe hash table, whatever, right? So now we say that it's going to instantiate a G, which is generic to be a student, which means every element in the collection should be a student type. Okay? So this is the static type of any element in the students. And when you talk about SSI, you're really referring to a particular students in the collection, right? That's why it has a static type, students. Okay? Okay, let's go over the slide very quickly, and then we got some little exercise in the next slide. Okay? Okay, so now, okay, line number 2, this is where we declare each element stored in the linked list should be just students, right? Let's go line by line, systematically. From line number 2, you know that SSI has static type students, okay? What about line number 3? Over here, you know that every time when you're trying to add something to this feature over here, the static type should be S, which is students, right? And line number 7, over here, we know that every time when you are, so I will illustrate this to you next slide. Whenever you're trying to call the feature get students, for example, 1 or 2 or 3, what can you assume about a return value? All that you can assume is the static type is going to be students. Okay? And we'll get to dynamic type in just a moment. Dynamic type is what makes so interesting. Okay, so now, and we know that SSI is a descendant class of this result, right? That's why it will compile. Now here's a question. Look at line number 11. Can we just say line number 10? So that's the typo, sorry. So line number 10. Let's have a look at line number 10. We are doing an assignment here. We agree it's going to compile, okay? Because based on our analysis on the static type, they compile. But now the question is different. At the runtime, what can be the dynamic type of result? What can be? How many possible dynamic types can we get for result at the runtime? 1, 2, 3, 4. How many? 3, right? Yeah, students, resident students, and non-resident students. Okay, so here, be careful. So now hopefully you're more comfortable. Whenever we talk about static type, only compile time. Dynamic type, runtime. I will illustrate to you why. At the runtime, you may have more than one dynamic type. That's exactly what polymorphism means. Okay, something can have different shapes at the runtime. Okay, all descending classes of students, right, which include itself. Okay, one more example over here. Let's say we got again RS and RS over here, and then we got course C and SMS. Okay, let's say we have resident students Jim with some premium rates, and we have NRS with Jeremy. So now a question for you. What is, after this line, what is the dynamic type of RS? Dynamic. Resident student, right? Remember this is shorthand for when the static type and the dynamic type are the same. Okay, just don't forget. And for this one here, dynamic type is non-resident students, right? So far so good. So now we got two objects with different dynamic type. Okay. And we got SMS. Now we say SMS.addS, SMS.addS as well. So we're adding two different objects into the array, to the list. So now let me draw a diagram just to show you very quickly. I think it's rather important. Okay. So now we have SMS, which points to some student management system. And one of the attributes called SS for students, which is a linked list. And now it turns out it has, okay, so we say SMS dot add S, RS, SMS dot add S, and then NRS. That's what we have, right? Just to remember. Okay, so we're gonna add in RS and MRS. RS is Jim, NRS is Jeremy. So that means the first element in the list is going to point to a RS students, Jim. The second one is going to point to a different object with different dynamic type, which is Jeremy. Now you can see that the header for the class over here are the dynamic types, right? And now don't forget over here, let me say it again, SS over here, static type of SS at any position I is students. That is why we can assign RS to students and NRS to students. Okay, again, just to visualize it. Okay, now here we are trying to register them for 3311 for both students. And now, can you imagine why this result is going to be assigned to true? When we say get students 1 is a parameter. By the way, because 1 is primitive, it's called by value, right? Just to review. And in the second one, we have get students and 2. Okay? Now, let me ask you this. Why is this particular feature called compilable? Why would it compile? Just for this particular one. Oh, since we talk about compiler, right? Is? No. That's okay. Go ahead, yes. No. As soon as I hear dynamic type, that's another answer. I talk about whether that line should compile or not. Huh? What's the question again? Why would this highlighted part compile? Is what? What static type is students? Okay, we're getting somewhere, Minjay. Okay, okay, very good. How did you, okay, do some, you want to say something before I say something?
That what he said, and in addition, the student class has the future
Tuition, okay. So now, okay, I think that you guys are really pretty much right. Okay, let me just, how about repeat what you just said. If you look at get student 1, what's the static type of this particular expression? Okay, in this one here, get student 1, the way you can figure that out is by looking at the declaration for that, which is students, right? So the static type of get student 1 will give you students, and then tuition has students. Okay, now let me just give you something more, which is not on the slides. Okay, let me write it down. I think it deserves a little bit more example. Just let me say that. Okay, I think we just got good timing. Okay, let's review what we have. So we have get students. So that's the student management system. Okay, that's what we have, the class and end. Okay, get students I, integer, I'll say int, which returns students. So this is static type. And let's say we try the following. If I say SMS dot get students, just in general, if I say 1 over here, dot tuition, SMS dot get students dot set premium rates dot set discount rate. Okay, now will they compile? Which one? Okay, let me say this is 1, this is 2, this is number 3, right? So the prefix is the same. First of all, 1 we know that it compiled. Let me explain again why 1 compiled, and then we can judge the rest. Over here you have that, over here, static type of return value of get students is students. And student class does have tuition defined. Now, applying the same argument, would number 2 compile? Let me give you a hint. For number 2 here, remember the diagram over here. The first one is the resident students, which does have premium rates, right? So should this compile or not? Yes or no? I heard no. Again, I'm trying to say dynamic type to confuse you, right? Again, don't be distracted by my confusion. Every time I say compilation, consider static types only. Yeah, go ahead.
So because if the static type is a student, he would compile.
No, it wouldn't, this one. But the student class have set premium rate though. It doesn't, right? Yeah, it doesn't, right? Good. Yeah, wouldn't compile. Okay, what about this line here, number 3? Would it compile? No, right? Because the static type for this expression here is students. Student does not have set discount rate defined. Okay, guys, this one is not in the slide. Make sure you study that, okay? Please, okay? Okay, I'm almost done. Just give me 1 moment, okay? You can review that. Okay, concluding slides. So now, I remember you asked me this question. I forgot your name, but anyway, Reds. You asked me a question about why we need inheritance there, right? If sometimes, question is a little bit like that, okay? I'm just being a little bit oversimplifying your question. Hopefully this slide will answer your question, okay? So whenever you're trying to declare a reference variable, especially you got inheritance present, the type you choose as the static type is a design decision, okay? I'm trying to illustrate this point to you. Let's say we have this, okay, attribute A of type T. I'm going to give you some student example in just a moment. So now, you want to choose the static type T such that accumulates all the features you think you will call in your program. Okay, what do I mean? For example, let's say this. If I have S of static type students, if you choose this, you should know that the consequence is whenever you refer to S, you can only call S.tuition. You cannot say S.set premium rates and S.set discount rate. I think your question was, If we couldn't do that, why do we need that? Right? Something like that, right? The reason is, if you find that after this declaration here, you constantly have to do lots of casts like this. I want to cast S to be a resident student, and then I can do set premium rates. As you can see, doing a cast is quite an ad hoc way of doing things, not just in iPhone, but also in Java. It's going to pollute your code quite a lot with a lot of cast expressions. If you find that after declaring your S of your students S to be of static type students, you got to do lots of casts. That means your design decision initially was wrong. You should have declared it as something else, maybe just resident students. Okay. Okay, that's my point. And then the similar arguments, similar design principle apply to whether the feature argument should be students, resident students, or non-resident student. That's why I show you different possibilities over there. And also the return type as well. Okay, guys, any questions? Any? Okay, that's pretty much finished everything, except that I will answer your question about the cast Samsung thing. I'll mention that on Wednesday. On Wednesday, we're going to talk about a design pattern related to inheritance. Hopefully that'll be interesting. Okay, see you on Wednesday.